So for this little video, we're just going to take a look at some basic geometry principles, how to identify certain shapes, that sort of thing, as well as calculating perimeter and circumference. Now the difference between them is not a whole lot. Circumference is from Latin referring to the aroundness of something. To go around is to circumvent. It's to travel around. So circumference measures the aroundness. Perimeter, which comes from the Greek perios, meaning to look or around, and meter, meaning to measure, is called a round measure. And so they're kind of the same thing. Just one has a Greek derivation and the other one has a Latin derivation. But so you can kind of think of circumference being the perimeter of a circle, and the perimeter of a square as being the circumference of it. It's a little bit weird, but we tend to have curvy things having circumference and squarey things having perimeter. So I'm certain that if you have had geometry before, you probably were forced to memorize 47,000 different formulas about how to find perimeter. There's no magic here. In fact, if you want to find perimeter, just walk around it. Add up all the sides. That's really it. That's all you do. So if, for instance, you have a rectangle, and this is going to be kind of a jacked up rectangle, but it's trying. Let's say this is 7, this is 7, this is 3, and this is 3. Then I would start in this corner. I would walk that and write that down. So I went 3. And then I would stop and I'd walk this side, and that would be plus 7. So I'd walk 7 more. Then I'd walk this side, so I'd walk 3 more. Then I'd walk this side and I'd walk 7 more, and oh look, I'm back to the same corner. So 3 plus 7 is 10, 3 plus 7 is 10, 10 and 10 is 20. I'm sure that if this is not your first rodeo, you probably saw something like, well, it's 2L plus 2W. Is it really? Sure. That's fine. So it's 2 times 7 plus 2 times 3, which gives you 14 plus 6, which gives you 20. Okay, fine. Yeah, sure. So advantage to not using the formula and thinking about it as just adding up all the sides, you may want to, or you may have an irregular shape. So you want to put a fence around it, that sort of thing. How do you put a fence around it? Well, by walking the perimeter. But it's not a regular shape. It doesn't have a formula. Oh well, you still got to get the fence up. So thinking about it as adding up all the sides, it kind of sort of tends to make things easier. Plus, you may have some really weird kind of janky shapes that I'll show you in a little bit. So on the circumference side, this is the circles and their cousins, the ellipsoids and that sort of thing. We won't, at this level, we don't talk about ellipses. They're kind of weird kind of funky shape. They don't behave well sometimes. And so the circle then is just 2 times this magical pi, which is roughly 3.14, times the radius, or you can call it pi times the diameter. Either way, if you have a circle, the diameter is the chord. A chord contains 2 points on the circle, 2 distinct points. If that chord contains the center of the circle, then it is known as the diameter. To measure, or to half measure, to cut in 2. And then that's the measurement that would cut it in 2. And then for the other, we have this, the radius. To radiate means to burst forth from. And so it has a center point. This is our radius. Radius is half the diameter, diameter is twice the radius. Either way, it doesn't really matter. And so to get the diameter out of this, it's just 2 times the radius, and that's it. That's why these two are the same. So pi is a magical number. It is quite literally defined by the ancient Greeks as the ratio of a circle's circumference to its diameter, which if you do the algebra beyond that, then it becomes diameter times pi is equal to the circumference. Ooh, special. They could estimate it. They said it was roughly equal to 3.14, and I've seen things that perhaps Archimedes got up to 31416 using a 96 gon. Sure. There's some evidence to suggest that the ancient Egyptians used the fraction 22/7. They're both right there, and both of them, neither one of them correct. So, yeah. All right, let's do some examples here. We're going to take a look at some basic shapes. The parallelogram. Now, the parallelogram isn't defined by this, but opposite sides being parallel, two pairs of opposite parallel sides. That is part of the definition. As a consequence of that, the opposite sides are in fact equal. And so, if I gave you, and this is covered into the rectangle, the rhombus, which is a diamond shape, but it's equal on all sides. It doesn't have to be a square, and the square. All of these shapes are kind of roughly the same. In fact, in the idea that they're parallelograms. And so, if I give you any adjacent sides, any sides touching, like this is 3 and this is 4, this is 3, this is 4, this is 3, this is 4, this is 3. Oh, it can't be that can't be. It has to be 3. And then this is 3 and this is 3 for the square. All you have to do is go to the opposite side, and that becomes the thing. So this is going to be 3, this is going to be 4, this is going to be 3, this is going to be 4. The rhombus and the square all have equal sides, so they're all the same. And then you just add them up. That's it. That's all you do. Just add them up. Don't think about having to write a formula down. It doesn't matter. So just add them all up. So in these two cases, you get 14. In these two cases, you get 12. That's it. Just add them all up. There's a couple of other main quadrilaterals that they tend to introduce in high school. We only really concentrate on one of them in college for some reason. The kite is defined in high school. I'm going to accentuate this here. Basically, if a parallelogram and a kite had a baby, it'd be a rhombus. That's essentially the idea. But a kite has these two adjacent sides are equal, and these two adjacent sides are equal. So it's a little bit weird. It's not quite a parallelogram because it doesn't have to have parallel sides. And so it's kind of a separate thing. But if you take a kite and you marry it up with a parallelogram, you get a rhombus. And that's really it. Where the opposite sides are parallel, but all sides are equal. No, it does not force it to be a square. The last one is a kind of a jacked up looking shape. It comes in a few different flavors, but essentially this, and the definition changes depending on who you ask. If you have a single pair of parallel lines, and that's it, just a single pair. This is where the change in definition goes. If you have exactly one pair of parallel lines, or in the inclusive, if you have at least one pair of parallel lines, you have a trapezoid. Trapezoid. This comes from a mixture of Old French and Old English. Trap meaning really, and zoid meaning are you kidding me? No, that doesn't come from that at all. But it's just such an oddball shape. They have to give you in the perimeter. They have to give you all four sides because this is also a trapezoid. It might look like a square or a rectangle, but then it comes down. It's just kind of goofy. That's also a trapezoid. If these two sides are the same, it's known as an isosceles trapezoid. Either way, same idea. You gotta have all four sides given to you because they don't no two of them have to be the same. So that's it. So if I give you like 3, 4, 5, and 8, you're like, whoa, that's way longer than 4. The picture's just there to kind of guide you. It's not a requirement. Then I have 3, 4, 5. That's going to be 12, and 8 is 20. So this will be 20. That's it. You just add them all up. It's always the same. So now, how about I take something that I'll try to draw this out. We'll see how this goes, but it could be a hot mess. I'm going to need a straight line here. I'm going to need a straight line here. I am then going to need a rough halfway point, and then I shall draw in a sine wave, sort of. And then down here we have a half circle. Use your imagination, please. I'm not a perfect drawer. There. So now we have some values. Let's say the radius of this particular circle is 2. This radius is 2. I am purposely not putting in units because I'm lazy. This is 6. We're going to consider this to be the same length and parallel. Much like the if you take a look at kind of the reddish and the purplish down at the bottom, it sort of looks like a track, like a running track. So the two sides are of equal length and parallel, and then you have a semicircle top and bottom. Well, our semicircle in the top is kind of janky. But we are told that this is 4 inches here, which kind of makes sense considering the other end. And we want to find what is the perimeter of this. Well, obviously there's not going to be a good formula for this. This is terrible. And they should feel bad for having drawn this. So we pick up the pieces. I'm going to call this 1. This is number 1. This will be number 2. We'll talk about how that all works. And then this thing will be number 3. So if I have number 1, it is a circle, and we know its radius. So let's use the radius version of it. It's 2 pi r. If we go ahead and find this is going to be 2 times, we'll call it 3.14 because, again, lazy. Because we can really use the calculator easily here. And then we have 2. That's going to be 6, 18, 6 times 14 is 84. This is going to be 1884. And now that's just going to be whatever units we have. The perimeter is always in single units. It's not squared or cubed. Then we will move on to this one here. Now this one also has a radius of 2, and we also have half of this. In effect, between these two pieces, we actually have the upper half of a circle and the lower half, which means if we add them together, we get a full circle. But just to keep with it, number 2, our circumference is 2 pi r because we're given the radius. And so this is going to give us 2 times 3.14 times 2. Oops. Wow, you guys let me do that mistake. Okay, we're going to go back and fix this. Ignore this. That answer is not correct. So if you've already gotten that and you're like, hey, that answer is not correct. All right, well, just this. See, it's just good. It's always good to go back and check your work. So we'll do this now. 2 times 2 is 4, times 3 is 12, but 4 times 14 is going to be 0.56, so 12.56. This also has to be 12.56 because it's the exact same setup. So we had to go back and make that change. And then we have 6, and we have 6, and now we need this piece, so number 3. This is going to give us a half circle, so we're going to take this and we're going to say, you know what, that's, oh. We're going to need to splice that in. Let me get down here. I'm not redoing that whole thing. Okay. So let's start with number 1. We'll take number 1 and consequently number 2. And the reason why we're going to do this is because they're kind of the same. So if if I think about them this way, I actually have a full circle. Here's the top half and here's the bottom half. I could kind of fake it and do that, but I'm going to do them individually just to show you. So for number 1, the circumference of a circle is 2 pi r. We're going to have to be, excuse me, we're going to have to be kind of cautious here. And so we take 2. I'm going to take 3.14 for pi just because lazy and calculator stuff, times 2. The other 2, the kind of 2 that's not an r. All right, and that is equal to 2 times 2 is 4, times 3 is 12, 4 times 14 is 56. Now we have a distinct issue here, and that is that this represents a whole circle. But number 1, that's only a half circle. So we got to cut that in half. So if we cut that in half, we have 6.28. Then we move on to number 2. And again, our circumference is nothing more than 2 pi r, but we got to make sure that's only half the circumference that we're looking for. So you can do that now, or you can do it later. I'm going to choose to do it later. So 2 times 3.14, and then times 2, and that's going to give us our 1256 again. But again, we only have half of it. So we take half of that, so it would be 6.28. Here's where you could have done yourself a little bit of a favor. If you had noticed that number 1 was kind of at the top half of a circle, number 2 was kind of the bottom half of the circle, you could have gone ahead and thought of both of them together as one complete circle, done the thing once, and you would have gotten 1256. Otherwise, we end up having to add them together, which is perfectly fine. Number 3. Number 3 is this circle, this half circle down here. Just assume it's a half circle. I know I'm a terrible drawer. So this is going to be, the circumference is equal to 2 pi r. Until I have it memorized, every single time I use one of these formulas, I write it down. So my circumference is going to be 2 times pi, which is 3.14, times r. In this case, it's 4. So we have 6.28 times 4 is going to give us 32, 12, 8. Ew. Should be like 25, 12, but I'm going to do it on the calculator. So 2 times 3.14 times 4. 25, 12. I should probably listen to myself more often. This is 25, 12. But again, we have to realize it is a semicircle. It's half of a circle, so we only need half of that. So that's 1256. So if we take that and divide that by 2, we do in fact get 1256, which means my brain is still functional. And again, these are all units. So whatever your units are, that's what it is. So I'm just going to put UN for unit. All of them must agree, by the way. You can't go inches and then change to meters and then change to feet. It doesn't work that way. So now we just do what we set up there. So what's the perimeter? Meter. The perimeter is just add them all up. So if we start here and I travel clockwise, I am going to get 6.28 plus 6.28 plus 6 plus 12.56 plus 6. And so my plus 6.28, 6.28, 6, 12.56 carries me around here, and then another 6. 1, 2, 3, 4, 5 individual measurements. 1, 2, 3, 4, 5 individual measurements. And if I add that all together, 1256 and 1256 is 2512 is 3712. And that's it. That's how you do it. But it's just a little bit at a time. Just a little bit at a time. Every single time it works like that. You just add up all the sides. That's it. That's perimeter. Keep it easy. Hope this helps.